Hi there, I'm Hao, and this is just another video of me solving randomly code problem. So number of space cleaning robot clean. So a room is represented by zero index 2D binary matrix. A zero is an empty space and a one is a space with an object. Top left corner will be empty in all cases. And a cleaning robot start at the top left and then facing to the right side. Right, the robot will continue to heading straight until it reaches the edge of the room, or it hits an object. So after which it will turn 90 degrees clockwise and repeat the process. The starting space and all spaces at the robot are clean by it. Okay, and we need to return the number of clean space run by the robot indefinitely. Okay, so the robot gonna start here, right? And let's use it's easier to see. Okay, and it's gonna go right. Right. So it clean this way, right? So now it reached the edge of the room, right? So it will turn 90 degrees clockwise, so it's go down. Right now it reached the edge of the room again, so it turned 90 degrees, right? Here and here. Right, now it reached 90 the edge of the room again, so it turned 90 degrees up, right? So it reached an object, right? So it turned 90 degrees again, right? And keep going back, right? And here it reached the edge of the room again, right? So it turned 90 degrees, just now, right? So at this point, we stop, right? Because we all, so if we encounter a position that is right, if we encounter the same position, right, with the same direction, right, then the robot stop, right? So we stop when the robot visit the same row and column, the same square, with the same direction twice, right? And then as we iterate, we're just keeping track of clean space. And then remember that the robot, right, can turn back, right? So we need to keep track of the clean space in the set so they don't have duplicate. Okay, so yeah, that's pretty straightforward. So the question now is how do we change direction? So we can have like a direction array, right? Equal to 0, 1, 0, -1, and 0, right? So the row, the next row, right? Will always be equal to the row plus the direction, right? Of the current direction, right? So let's say this is direction. It is the direction, right, of the current direction, right? So the current the direction is starting out at 0, right? Right. So zero means we are going to the the right. One means we are going down. Two means we are going left, and three means we are going up, right? Right. So next column gonna be equal to a column plus the direction, right? At the current direction plus one. So at any point in time, this is how we get the next move, right? So let's say the direction now is 0, right? Which is the index 0. Index 0. Index as index 0. So which means we are going right, right? So the row is the current row at the direction, right? 0, which is 0, right? So we are on the same row because we are moving to the right side, right? So that the row doesn't change. But for the column, it is the direction plus 1. So it is index 1 right here, right? So column equal to column plus one, right? So we keep the same row, but we increment the column every time to moving to the right, right? Because we are going to the right, index zero here, right? Whenever we want to change direction, we just have to increment the index, right? Increment direction by one, mod by four, of course. So now we are going down, right? So if we are going down, the column stay the same, right? The column stay the same, but the row is changing. So as you can see here, right? The direction is index one. At index one, row equal to row plus one. Right? So the row is changing, but that direction equal to index one plus one is index two, right? Which is zero. So the columns stay the same, right? Similarly, we have the next one, right? Which is going to the left. We be going to the left, right? Then the row gonna equal to uh, index two, right? Which is the row is not changing, right? But the column is changing, right? The column is changing by adding negative one here. It is changing, is keep decreasing so that we can move to the left, right? And then lastly, moving up, right? If we move up, um, the row the row is changing, right? But the columns stay the same, right? And we can see that the columns are the same here, but the row is keep being decremented, right? So yeah, we can use depth first search to do this. We can just keep moving, right? Based on the next row and next column, based on the current direction. If we reach an object or an edge of the room, we can just turn at 90 degree by incrementing the current direction, mod by four. And we stop when we see the same tile again, right, with the same direction. So because we have four direction, right? So our time complexity gonna be O of 4 to the n by n, just O of m by n. So yeah, let's code this up. So we will need a rows and a column. Rows equal to room dot length, columns per room 0 dot length. We need our direction, right? Direction equal to 0 1, right? 1 0, and then 0 negative 1, and then negative 1 0, right? We have a visitor set, and then a clean set, and return clean at row. You start out at the top left, right? So 0 0, and then the direction gonna be toward the right, right? So index 0 for the current direction. So the visited here, right, gonna is a combination of row, column, and the direction, right? When we see the same row, column, and direction again, which means we can break out the loop and return, right? The clean here is to, because the robots can move backward, forward, right? So we need to keep track of the clean space in the set so that there's no duplicate. So this is only consists of row and column. So we have a clean, back in a row, a column, and the direction. Okay. So we need a check if it exists, right? If the current position is already exists, right? And that gonna consist of the row, the column, and the direction of two string. So and the clean key equals to the row, only the row and the column of two string, right? So if visited dot pass the visited key, right? We can return the clean front size, right? So when we see the same tile again, with the same direction that the robot is moving, right? If the robot is already clean the tile, right? Already moved to this tile, right? With the same direction, which means we can. So if it does not exist, we can add it to our set, right? And also keep track of the clean space. Okay. After that, we need to clean the next tile, right? So we need to calculate the next row and next column. So next row equal to row, right? Current row plus the direction at the current direction. Right. Next column equal to the current column plus the direction at the current direction. Right. Plus one. Remember? Right. So if we are moving right, it is the first two, right? The current direction is zero, right? Which is the row gonna stay the same, right? By adding zero, but the column must keep changing, so we can move to the right. Okay. So if next row, if valid is invalid, if next row and next column are invalid, right? And then we need to make sure that it is not it has to be an empty space, so it has to equal to zero. So if this is the case, we can keep moving, right? So which means that reached we haven't reached the edge of the room yet, and then the next row and column to the next position is not an object, right? It is an empty space, so we can keep moving forward. So we can pass in the next row, the next column, right? And then the direction that we are currently having. Okay, if if it is if we reach the edge of the room, right, or an object, which is why it will return false here, right? So we have to turn 90 degree clockwise, right? So we pass in the old row and column, right? Not the next row and next column, because the next row and next column are invalid, right? So we pass the row and the column, and then we change the direction by doing that direction plus one, right? And we have to modify the direction of line, modify five actually, yeah. So that we make sure we are not going out about in the array, in the direction array. So I think that's pretty much it. Let's give it a try. Okay, let's say 3 and 7, 8 and 1. So let's double check our logic here. So we have our constant here, row and column, that's right. And then our direction, 0, 1, 0, negative 1, 0, right? So 0, 1 to move right, 1, 0 to move down, 0, negative 1 to move left, and negative 1, 0 to move up. And we have our two set, visited and clean, right? We have our key, right? Visit key, which consists of the row, the column, and the direction, right? The current direction. And we start out by at the top left corner 0, 0, and the direction is 0, which is moving to the right. Okay, so if visited had visited key, then we have to return, right? Return the clean dot size. And then if not, we add the square into current position into the set. And then we calculate the next row and next column. The row is just equal to the row plus the direction of direction, right? The column is equal to column plus the direction of the direction plus one. And then we check see if everything is inbound. So next row, next column, less than rows, less than column. and then it has to be an empty space. So in that case, we can return, we can keep spinning the next tile, right? Keep moving in the same direction, and we pass in the next row and next column. Okay, this looks right to me. And then if it is not valid, which means we reach an object or the edge of the room, so we need to put in the same row and column and then change our direction, right? 90-degree by increment the direction by 1 and mod by the direction of the line. Okay, this looks right to me. Not sure why it won't work. Um, hmm. Oh, yeah, I have a typo here. Should be column. Okay, and it worked. Oh, 100%. Thank you for watching.